Hi, my name is Gracie Han. I'm here to present our final project in Data 620 along with Oma and Don. We chose to use the Twitter database during pandemic, which is in trackmyhashtag.com. We did some EDA and then the sentimental analysis on the data to understand the user's opinion. And also we produced some machine learning algorithm, naive Bayes, decision tree, and random forest to compare the performance on predicting the positive, negative versus neutral tweets. With that being said, here are the packages that's needed, and here are the data in CSV file. We can see that the data has 60,000 tweets and 22 rows in 22 columns in their IDs, time of tweet, users, etc. So we decided to drop the NAs and then did some EDA. So here are a plot of where the data come from. It's very not surprisingly that the majority of them are from the phone, Android and iPhone, and only less than 30% are from the PC. And the non-verified is the majority of them, which is around 90%. Only around 10% are verified. And here is a look of how this data look like. As we can see that they are from all over the place in around the world. And here are the dates that we scraped the data until February. So not surprisingly that the majority of them are in the week of ends in January the 31st, and then the week prior to that there's much less. Looks like people have relatively long sizes. Majority of them are in hundreds to 200 counts. And location wise, most of them are in United States, and here there's a few Twitter did a few locations that indicate both the United States, all United States, USA, Washington, D.C., New York, etc. And ranking by the country, yes, United States has majority of the tweets. So next is that we are trying to do the sentimental analysis. So here are cleaning of the tweets, remove the punctuation, and then the lambda function to stitch back the tidy tweets, etc. So and then we also normalized the tweets that use functions to generate word counts, and then group by negative, neutral, and positive. So here are the functions that's needed. And then we look at the distribution of the unique words. Here they are. The top one as coronavirus, second as China, Wuhan, and then etc. And so here is a word cloud of the above unique words. And here's the pie chart distribution. As you can see, 36% are containing the words coronavirus. At that time, COVID-19 was not popular yet. I'm sure that the later tweets will have COVID-19 rather than coronavirus. Here we are mapping the popularity values to different labels. So here are the most popular ones. apps, the contents of them, and then how many times they are retweeted, etc. So by popularity, despite the nature of the pandemic, most of the tweets are neutral. It's stating the fact. And there's more positive than negative, so people are resilient. And here are the positive tweets. WHO says it has increased its assessment, etc., etc. So people are trying to spread the information or the fact. So they are, rather than tweet about their negative feelings. And then the negative feelings are China, mostly about China and etc. So here are examples of the neutral tweets. So then the sentimental distribution tells us that again, neutral is half of them, and positive tweets has slightly more prevalence than negative tweets. And here are in another way by number of tweets. So in total there are 60,000 and 35,000 are neutral. So the next step, we are applying the machine learning algorithm to predict the neutral, positive, and negative. We chose 3 machine algorithms, which is naive Bayes, decision tree, and random forest. So first, we are preparing the data for naive Bayes, and then we also then the next is split the data into training and testing with 25% as testing and 75% as training. And here they are as a peak that there are actual negative but predicted as positive, etc., but majority of them predicted right. And then we will have the details later. And the naive Bayes classification accuracy is that it's 98% accurate for the neutral, and 78% for the positive, and 34% for negative. So it's the negative one is that they produce that the prediction is much lower. And second model is the decision tree, and we use the entropy criteria. Again, splitting the data, and then print out a peak of how the actual versus predicted. And then here is the performance report. As we can see that the positive and the neutral prediction are similar or a little bit improved from naive Bayesian, but the negative prediction, the negative tweet prediction is much more improved. Remember that it was in the 0.3, now it's improved to 0.89, so it's much more improved. Third model, we chose random forest model. Again, did the training and testing split, and here's a peak of the actual versus predicted. And then the performance report tells us that the precision level for positive and neutral are similar. But again, the prediction for the negative tweets has much more improved from naive Bayesian, 2.95. So in summary, among the 3 models that we chose, decision tree and random forest perform similar, and naive Bayes do not perform as well, especially in the prediction for negative tweets. So here is the conclusion of their performance side by side. Finally, we also try to attempt to do the network analysis by looking at the tweeters and then the followers ID to see who's connected and do eigenvector analysis like that, but we could not do it. The main reason is that the dataset do not have the followers ID, only have the tweeters ID, so we regret that we cannot do that part. Thank you so much, and that concludes our final project.